So in this example, I'm given a system of linear equations, and I want to find the solution and express that using our set notation. So here's my system of equations. I want to start by setting up an augmented matrix, and then I'll row reduce and use that to come up with a new system of equations that is equivalent to this one, but much simpler. And from there, we can see how many solutions we have and then express our solution using the set notation. So let's convert this into our augmented matrix. Remember, we have a column for each variable. So I can either go from left to right or from top to bottom. So I'll go first focusing on x1, and I have 1, -1, 1, and 0. This is where it's convenient to have the variables arranged where all the x1s are together, all the x2s are together, and so on. That way I can easily see that first column is 1, -1, 1, 0. Then in the second column I have -3, 3, -3, 0. Then 1, 0, 3, 5. And then 2, -2, 3, -4. And then 2, -2, 4, and -8. So I have 5 columns so far because I have x1 through x5. Then I use a vertical line to distinguish between the coefficients and the constants, and I get -1, 3, 1, and 18. And you can check yourself here to say, okay, x1 minus 3x2 plus x3 plus 2x4 plus 2x5 equals -1. That's my first equation. I'm good to go. And the other three will work exactly the same way. So I've started by writing my original augmented matrix. Then I need to compute the reduced row echelon form. And I can do that using my calculator as long as I've written the original one and the result of what I get. Okay, so here we get 1, -3, 0, 0, -2, then my vertical line, and 1. Then in the second row, 0, 0, 1, then 0, 0, 2, and then we have 0, 0, 0, 1, 2, -2, and then finally an entire row of zeros, so 0 is for everywhere. Okay, so now I want to go back and write this as a system of equations. So I have x1 minus 3x2 minus 2x5 equals 1. Then x3, nothing else, equals 2. And then 1, 2, 3, 4, x4 plus 2x5 equals -2. And then 0 equals 0. Okay, so let's observe this for a second. I have a situation where I have no contradictions and my variables are not isolated. I don't know, like x1 equals this, x2 equals that. So we're going to have infinitely many solutions. And when I have infinitely many solutions and I need to write my solution, I need to introduce parameters. So to introduce parameters, we need to think about which variable columns have pivots and which don't. So let's identify those here. So I look in each row for the first non-zero number, and those happen here, here, and here. And remember, if we've row reduced correctly, we should have all those be 1s, right? That's one of our conditions to be in reduced row echelon form. The first non-zero entry in each row is a 1. So that's what's happening here. So these are my pivots. And those are the ones we don't want to be equal to a parameter. All of the other ones we will set to be parameters. So this one does not have a pivot in that column. So I'll say that x2 is equal to a. And then this last column before the vertical line also does not have a number circled. So I'll say that x5 is equal to, I'll use a different letter, b. So eventually, my goal is to rewrite all of the variables, x1 through x5, so that they're either equal to just a number or some expression containing a's and b's. And I'll use these equations to do that. So I'm already done with x2, x5, and x3 because they're equal to a, b, and 2. But I need to write x1 and x4 in terms of the a's and b's. So let's take this first equation, x1 minus 3 times x2. Instead of x2, I want to write that as a. So 3a minus 2 times x5. x5 is b equals 1. Now I can solve this equation for x1 by adding 3a and adding 2b to both sides. So x1 is equal to, 1 plus 3b plus 2b. Okay, then I'll do the same for x4. x4 plus 2x5, so 2b, equals negative 2. And now, again, solve for x4. x4 is equal to negative 2 minus 2b. Now, they're kind of in different spots, right? I have x1 here, x2, x3, x4, and x5. But the key thing is I now have all of them completely in terms of either numbers or multiples of a's and b's. And that means I'm ready to write my solution. So my solution is the set containing vectors. Okay, my vectors will be in R5 because I have 5 variables. And I need to put in what the x1, x2, x3, x4, and x5 slots look like. So x1 is 1 plus 3b. Oh, sorry, this should be 3a. Let me fix this real quick. So I have a little mistake there, a little mistake here. Excuse the squeaking. So if I added 3a to both sides, this should be 3a. So 1 plus 3a plus 2b. Okay, then x2 is a. And then x3 is just 2. That's fine, right? x3 has to be 2. There's no option. And then x4 is negative 2 minus 2b. And x5 is b. So the solution is all vectors of this form. But I'm not done. I have to say what a and b are. So I say such that a and b are in the set of real numbers. And I'm kind of overlapping here, so I'll circle this to kind of emphasize this is our solution. Okay, so it's the set containing vectors of this form such that the a and b are any real number. So what did we do? We started with our system. We wrote the original matrix, computed the reduced row echelon form. That's what we got here. Rewrote that as a system of equations. Then picked our parameters. Rewrote the x1 and x4 in terms of those parameters. And then combined everything together for our solution.